Alright, so I asked you to have a look at diffraction of light, and basically this is just an extension of the idea of what's happening with the diffraction of waves. Okay, so if you draw two parallel lines and you leave a little gap, because that's where our diffraction is going to occur. Okay, so in that little gap, that's where our light is going to go through. What is actually going to happen is that the light will go off in a cone. Okay, so if you're drawing, if you're with me on the video, you can see it, but on the other hand, just try to draw a cone of generally whatever angle, not just whatever. So when a light wave goes through, if we've got monochromatic, meaning a single color, polarized, which means it's going in one direction, it's going to be parallel. And when it hits that gap, it will then start to bend just as we know it. And it will create waves which are going outwards. Okay. Now, as we can assume that when the wave actually touches the other side, it gets absorbed or reflected back, but we don't really worry about that. All the sections on the side, okay, even once it touches let's do this. Once it touches that side there, that is what we will see, all right? And what we'll see is that then we have that is touching there, this is touching here, and this is touching here, and here, and here. So we can see that when the middle wave touches the outside part, that is, or the screen, that is where it will now create a bright spot. Okay. Now, and the waves on the side, which are still not touching the screen, will then carry on. They will propagate. They'll continue to propagate. And when it touches the screen again, with the constructive interference, we get another bright spot. And then those waves will continue and continue and continue. Now, when we look at the picture of the intensities, where you have what looks like a wave graph, the intensities on the sides will be low, and then that one in the middle is the one that's going to be the highest, because that is the biggest wave, and it will create a brighter spot. Okay, so on my textbook there's page 179 where it will tell you where the central color band is the maximum brightness, and it is explained by the diffraction of light going through a grate, and it creates that bright spot in the middle where there is the most constructive interference. Okay, so that is basically the idea of the diffraction of light. It just follows the same thing as the diffraction of a wave, a physical wave. And obviously, because the smaller the gap, if we have a smaller gap, the more it diffracts. So we have more and more individual spots. If we have a big gap, if we have a bigger slit, we do not get as much diffraction. And that's what we talk about in terms of degree of diffraction being related to the wavelength and the size of the slit. Okay, because the greater the wavelength, the more diffraction that occurs, and the smaller the slit, the greater the diffraction that happens as well. Okay, so with that in mind, I do want you to do exercise 14. Because at the end of the day, there are not going to be calculations that have to be linked to this. It's just going to be mostly labeling. Okay.